Welcome to this lesson where we are going to discuss our similarity postulates and theorems. The first postulate that you should have in your math dictionary is called the angle-angle similarity. It states that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So in our previous lesson, we needed to know a lot more information. With this postulate, if we know that two angles are congruent, we know that the triangles are similar. Our next theorem is the side-side-side similarity, where if we know that three sides of one triangle are proportional to the three corresponding sides of another triangle, then the triangles are similar. So for example, if we can match up the corresponding sides, check that they have the same ratio, we can state that the two triangles are similar. And our third one that we have is the side-angle-side similarity, where if two sides of one triangle are proportional to two sides of another triangle, and their included angles are congruent, then the triangles are similar. So for example, if we know that the included angle of the triangles are congruent, so in this case angle C and angle F, then we can check to see if the sides are proportional, so AC and DF, CB and FE. Since those two sides are proportional, we can state that the two triangles are similar. So a few examples are: state if the triangles are similar. If yes, state how you know, and write the similarity statement. So looking at this triangle, I'm going to check to see if the triangles are similar by our side-side-side similarity. So we have to check the ratios of the corresponding sides. So that means checking to see if FE is proportional to CB. So that would be 25 over 70, which would reduce to 5 over 14. And then we can check DE over AB. So 15 over 42. And 15 over 42 gives us the same. We can divide them by 3, and that would give us the 5 over 14. And now we can check the last sides to see 30 over 84. And that leaves us with 5 over 14. So the three sides, corresponding sides of these triangles, are similar. So we could say, are they similar? We would say yes. How do we know? We know by the side-side-side similarity rule. And the similarity statement that we need to write is triangle ABC is similar to triangle DEF. All right, let's take a look at this example. State if the triangles are similar. If yes, state how you know and write the similarity statement. We've learned this previously, but when triangles share a point, this triangle shares point C, we have what's called vertical angles, in which these two angles are congruent. And if we check to see the corresponding sides, to see if they're similar, we would have 14 over 28. Well, they're both 14 over 28, which leaves us with a ratio of 1/2. So are they similar? Yes. How do we know? Well, we know because our sides angle side similarity. The corresponding sides are proportional and the included angle is congruent. And our similarity statement that we need to write would be triangle A, C, B would be similar to triangle E, C, D. Here it says, find the missing length. The triangles in each pair are similar. So if we know these triangles are similar, we know that they have corresponding sides that are proportionate. So the corresponding sides here would be QS over PW. And since we know that they're proportionate, we can find an equivalent ratio. We just need to find corresponding sides. We can use one set. We can use RS over VW. So if we fill in the lengths QS, that's the side that's missing. It's unknown, that's X. PW is 22. So we know that X over 22 is going to be equal to 6 over 12. And this goes back to our cross products. So if we solve this, we've got 12 times X. That would be 12X equals 22 times 6, which is 132. We can divide by 12 on both sides. We get X would equal 11. So QS is equal to 11. Last example. Solve for X, then find the unknown side length. The triangles in each pair are similar. So if these triangles are similar, we can set up a ratio or a proportion by using the ratio of their corresponding sides. So we can set up 4x minus 4. So EF is proportional to BC. So that'd be over 64. And then we can use ED, that'd be our 27 over 72. Now here, when we go to cross multiply, we have to take the 72 and multiply it by both terms. So 72 times 4x would give us 288x minus 72 times 4 would give us 288. And it's going to be equal to 64 times 27, which is 1,728. And we go to solving. We add 288 to both sides. So that would leave us with, I'm going to go up here, 288x equals 2,016. Divide by 288 on both sides. And we get x equals 7. So the first thing we had to do was solve for x. And now that we know that x equals 7, we could figure out the missing side length of EF by plugging in 7 for x. So 4 times 7 is 28 minus 4. EF equals 24.